Hello, this is David Wyatt from Automation Doctor Incorporated. I am here to demonstrate and show some of the features of the undercarriage visual inspection system Uvis developed for Duos Technologies. This is the rail prior to it being placed into its protective shell, and I'd like to go through some of the features. It's about 4 feet long, minus 2 inches, because it has to fit into a 4-foot enclosure, and it is divided into two halves. On the left hand side are the driver's side computers, the driver of a vehicle, like a trailer for instance, or a tractor. On the right hand side is the passenger side of the vehicle. We start in the middle, and there are terminal blocks here for interfacing a cable through the enclosure to come out and have a pigtail and off to the Uvis trailer inspection system. You'll see that later when I show you the enclosure. Let's start at the top rails. As you can see, these are 12 volt DC, half a million lumen LEDs per foot, and they are on either side, and they run the entire length of the Uvis inspection system. On the ends, there are additional LEDs for shining along the bottom of the FEMA trailer. One on this side and one on this side, this being the driver's side. You'll notice that they're sitting on an extrusion that allows for cooling fluid or air to be forced in here and returned out here to keep this entire vision system cool while still illuminating the part. Coming back to the middle, again, we said this is where the pigtail came out for interfacing into the trailer. There are two RJ45 converters here that accept individual signals for first the left-hand or driver's side computer and the right-hand or passenger side computers. In the middle also is a ultrasonic sensor. This sensor detects the overpassage of a trailer in this direction so that we can trigger the cameras and turn on the lights and such. This is a humidity and temperature sensor that senses the ambient temperature in the enclosure. There is another redundant one under here that does the same job, so each computer side has its own sensor. Each Pi computer is enclosed in this heat sink impregnable Raspberry Pi enclosure. It's made out of aluminum. It's been machined. On top, you'll find a 500 gigabyte portable solid-state drive for storing images. Although we did find out we could store images in RAM. There's a network connector that goes from each unit to a power over Ethernet gigabit interface. This is where we're getting 5 volts and also where we are interfacing to the trailer. As you can see, there's another one on this side. The camera we're using is a 5 megapixel version 1 camera, and it is mounted on a green circuit board that we built a mount for, and this particular one has an M12 lens. To facilitate interfacing, there is a breakout board here that interfaces to the Raspberry Pi through a ribbon cable. And this breakout board allows for signaling to the trailer plus control of the lights. This relay here, it's a solid-state relay, actually controls the lights. One side controls the upper lights here, and the other side, the passenger, controls the in lights. There's another solid state relay buried down here, and this one is for signaling the trailer. It has a code. It can be a heartbeat. It also is on solid when there's when there's an actual trailer being inspected. Plus, it's a status light, so it'll blink once to signify that it's ready to go. It'll blink twice when it sees a fault, such as a temperature fault, and 3 times when it sees a humidity fault. This allows the operator to have an opportunity to see what's actually occurring. This is the ultrasonic sensor control board with a very quick disconnect that allows us to easily change it through the plastic. Again, we have the same situation here. One of the things I didn't talk about was the pulse width modulation control board. That is this blue board here. And what we've done is we've allowed the Raspberry Pi to do a pulse width modulation to control the intensity of the lights. This side is the driver, and the passenger side, it controls the intensity of the in lights. The other one controls the intensity of the inline lights as opposed to the end lights. As you can see, everything has been neatly wired, and we used aluminum extrusion to act as heat sinks. There's 1, 2, 3, 4, 5 heat sinks on either side, and a special channel that the LEDs will sit in so that they will pull the heat away. And there is a Lexan cover that goes over the top. I will show that in a later video when you see the entire system in its natural state. Thank you.